do this. So we're gonna have to convert those zeros into binary. Alright, so putting them in binary, that is it. So this is with your network. So now we have to verify our network address. So our network address here is 172, because it's always the one that's given to you. That's 16.0.0 prefix 16, or you can call it CIDR 16, or you can call it /16. All of those words you can use it length 16, whatever, but let it just be that number, because that number tells you how many bits are part of the network and how many bits are part of the host person. And then and it may not tell you where to find or whatever, but it's telling you that the bits that are part of the network and the bits that are part of the host, or that are left for the host person, and they're only usable for the devices in the host person or end devices that you use in the network. Alright, so before we get those first valid IP addresses, the first thing we need to do now is, for my own best way, there are many ways that you can do to do subnetting. Okay, you can use many ways to do subnetting, but I feel that part of the methods that are used, this is the best. I'm gonna have to show you guys this. I'll show you guys about 3 different ways to do subnetting, but as of now, I'm just gonna stick to this one, and I make sure that you guys understand this one. And when I go to the next one, I'll show you guys how to do that one as well. So basically, this is the one, and the broadcast address, because this is the network address. So what you will do is, the sum of these bits is giving you an amount. Okay, if you add all this together, it will give you 255. Okay, all right. And if you add all of these bits as well here, okay, all of these right here, if you add them together, you're gonna have 255. But they're different networks. Okay, you just have to know that. Okay, all right. So that is it. 255 here to be added to this 0, and this other 255 here for this last octet will also be added. So you add the sum of the bits to whatever value for the same portion of the network address. So that is your network address, and this represents the third octet. So whatever value that is the sum of the bits in this third octet, you have to add it to whatever is in that same third octet of the network address, and the same thing applies to the fourth one, and whatever value that is in the fourth one. So here, fortunately, we have 0, 0. So 255 plus 0 gives us 255, and 255 plus 0 gives us 255. So the address starts as 172.16.255.255. So that is it. That's your broadcast address. Now, we need to now find the first valid IP address. So I'm going to just abbreviate that as F. The first valid IP address is always going to be 1 additional, so 0.1. So you always add 1 to whatever value that is in the last octet. So I have to explain this many times, and it's very important that you guys jot that down, because I saw Get did that somehow. He wrote those statements, he jot them down, so it helped him to go back. So it's important that you guys do those things. All right, so the last valid IP address will be 192.16.255.254, because this one would remain, okay, because this is not the last one. So you only have to reduce 1, subtract 1 from this. So which means this one you only add 1 here, and this other one you only subtract 1 here. So therefore the entire of this remains the same until you acceptly, or you reduce 1, or you subtract 1 from here to give you your last valid IP address right here. So that is one subnetting. So the subnet mask here, because we have 16 bits that represent the network. So how do we get this? You can do this. You can do this. Okay, you can actually do this. 16 bits represent the network is like this. Okay, it's like 1, 2, 3, 4, 5, 6, 7, 8 dot 1, 2, 3, 4, 5, 6, 7, 8. So that is how your address 1, 2, 3, 4, 5, 6, 7, 8 dot 1, 2, 3, 4, 5, 6, 7, 8. So this, what you have here, the network. Now this is it. The number of bits that are part of the network is this 16, and the number of bits that are part of the host is this 16. So this is exactly what I do. I do not convert this 172 and 16 into binary. No, what I did was, this 16 is ones of 16, okay, and then this other one is zeros of 16. So Exactly, that is what you are having. So if you convert this 8 bits into binary, into decimal, you have 255. If you even convert this also into binary, you have into decimal, you have 255. So that is how you get your subnet mask. So you can just abbreviate it as S 255.255.0.0. So you call this as classful side or classful subnet mask, okay? Because it is the subnet mask is based on the class, okay? Example 2. So we can just make 2 examples and that should be enough. Example 2, we can use the same thing. Now what is going to be the next network? Your clock. Remember your clock. The seconds 60, the minutes 60, okay? Now what do you think happens to the hour? It changes. So therefore in class B the third octet here changes to 17, because if you change this, bam, it's finished. Look at here, it's also 255. So therefore this value will change to 17 and then the rest will go back to 00. So remember your clock all the times. So the next network would be 172.16.0, sorry, that's 17.0.0. So the next one will be 172.18.0.0, next one 19, next one 20. It goes like that until the whole of this 17 also exhausts to 255. Then this one becomes 273. So that's it. Prefix 16. So the first valid IP address here, let's look at the broadcast address first. Your broadcast address would be 172.17.255.255, simply because we have the sum of these bits that are part of the host person, 255 and 255. Here we are each of, on each of these octets, so it gives us exactly that. So the first valid IP address, which I abbreviate as S, you can always get that if you want. So 255 172.17.0.1, and the last